did hour 2 back, and it can be due at the end of the week. I created hour 3, and let's get that done by a week from today. I think that's what I put in here. Let's take a look. Hour 3, the 26th, so I think that's Friday. So yeah, we have a little bit to do since we lost Monday. So anyway, get those things done and post up. You'll see in the submission area kind of the requirements that I'm looking for that extra information. Today, I'm going to talk to you about electricity. You've been through a movie about electricity, but I just want to go through kind of how conductors work and insulators work and kind of a little bit of the physics of chemistry. So let's look at this PowerPoint that I have. It's a pretty nice one. I'll admit right away that I have stolen it from somebody else with their permission. So there you go. Electricity, the movement of electrons. So like the reason we're going to go through this stuff is because everything in sustainable engineering, as far as the renewables go, is electricity, and electricity is a giant consumer of energy. So I think it's really important that students understand how it works. You take a electrical class, but I'm not sure it goes into the kind of detail I'm going to go into. Although at the same time, I'm not going to make you an electrical engineer, and you're not going to, do some crazy circuitry in this class. But I think a solid understanding of what's going on with electricity is super important. So, all right, let's look at this. So this thing is an invisible force that provides light, heat, sound, motion, and more, right? The atomic level, we have elements. That's the simplest form of matter, and we have atoms, the smallest piece of an element. So these are all elements, and then we have our atoms, right? And so let's learn about those. At the atomic level, we have these components of an atom. We have the nucleus, that's this inside part, right? Center portion of an atom containing protons and neutrons. So the red are protons, positively charged, and the blue are neutrons. They are uncharged, so they're not negative, they're just no charge, right? So the atomic number is generated, it's equal to the number of protons in the nucleus of an atom. So the atomic number is protons in the nucleus. Remember, this is the nucleus. So the atomic number identifies the element. So there's the protons in this one. Remember, protons do have a charge. There's 4 of them, right? All right. The electrons, they're circulating around the outside. They're negatively charged particles. So this is the 3D picture, kind of actually what it looks like if you could see it. Right, so these electrons are orbiting around the nucleus of this atom. All right, so the 2-dimensional image of that would look like this, right? There's 4 of them. So I'll go back 3D, see the 4 electrons. And there's 2 rings. All right, so there's 2 in each ring. That's this atom. The valence electrons are the electrons in the outermost ring of the atom. Those are the ones that will be activated when we transmit energy between these atoms, right? It's those valence electrons in the outer ring that can bump out and move. So it's going to talk about that. So here's a atomic level look at this atom. As we get more rings, right, there's more electrons. But the outermost ring is the valence orbit, right? It's the outermost ring closest to the nucleus will fill first. All right, this one happens to have 8 in the outer ring. We'll talk about that in a second. So let's look at copper. Copper is pretty unique in that atoms have their valence ring either filled or empty. They want one or the other. They want this thing filled or empty. So this one's filled. It has its 1, right, in the outermost ring, the valence ring. Now, how many electrons are in the valence? 1, I spoiled that, sorry. Is copper a conductor or an insulator? Well, it has 1 here, right? So that could easily be bumped. It's not like 8 of them have to be bumped out, just 1 has to be bumped out. So it is a conductor because it has a limited number of electrons in the outermost ring. Therefore, it would be easy to bump it out. If there was a lot of them, then it would be hard to bump it out. And an atom wants to either be filled with 8 or it wants it empty. So this, it wants to get rid of it. It's like encouraging to get rid of it. All right. So here's sulfur. It has 1, 2. Well, it'll show you how many electrons in the outer. It has 6. So is it a conductor and insulator? Well, it's full. It's got 6. Doesn't have 8, but it wants to keep them. Okay, it wants to keep them. So it's an insulator. All right. Electron flow. An electron from one orbit can knock out an electron from another orbit. So that's actually how electricity moves. So these atomic bumps are what happens. So let's look at this, right? One comes in, knocks it out, and sends it forward. That is the flow of electrons. There's a really good animation here that kind of shows you how this happens. So it comes out, bang, it's just gonna knock them. And remember, these are very close to each other. There's really no gap there. That's it. That's the flow of electricity. Of course, it happens so fast, incredibly fast. All right, conductors and insulators. Conductors, electrons flow easily, right? Insulators, electron flow is difficult. Doesn't mean it can't happen, it's just difficult. The valence electrons in outer orbit are 1 to 3 for the conductors, and they're 5 to 8 for the insulators. Some examples, okay? All right, let's keep going. Conductors and insulators, just to look at some physical things. Conductors are things like the metal, and insulators are things like the rubber and the coating on wires. All right, so let's talk about electrical circuits. A system of conductors and components forming a complete path for current to travel. So a complete path means that the current can travel somewhere, right? It's not just a wire with an open end. That would not be a circuit. We have properties of volts, amps, and ohms. All right, so let's look at each one. The flow of electrical charge measured in amps is like this water tank and pipe, right? When the faucet switches off, there's no flow. And when the faucet switches on, there is current. So that's the same kind of thing that we have happening in electrical circuits, right? There's a circuit. If it's off, there's just no complete circuit. And if it's on, there's a complete circuit. Energies can travel all the way through back to the battery, and the light can use some, right? So much energy is coming in, a little less is coming out, it comes through. All right, so we have conventional current, we have electron flow. Conventional current assumes that current flows out of the positive side of the battery and through the circuit, where electron flow, what actually happens is electron flow out of the negative side of the battery through the circuit and back to the positive side of the battery. So this is really what's happening, right? All right, so the direction that the current flows does not affect what the current is doing. Thus, it doesn't make any difference which convention is used as long as you are consistent. So yeah, this is really what's happening, but this is the same function as this, right? If you have the flow of electrons, you are going to have a current. All right, the force. The force is measured in volts in electrical circuits. So when the switch is off, is there any pressure on the voltage, right? When this is off, is there water pressure? Yeah, of course there is. It's pushing against the pipe tank and the faucet itself. When the faucet switches on, is there any pressure? Yeah, there's pressure, all right. The voltage pushes, this comes spewing out because of all the pressure. So yeah. All right, same kind of thing. The battery provides voltage that will push current through the bulb when the switch is on. So that's the push. The battery is the push. Voltage. All right, let's think about resistance. So ohms is the resistance to that flow. What happens to the flow if a rock gets lodged in the pipe? Right, rock comes down, boom, goes in and gets lodged. The flow decreases, right? Now we have a smaller amount of flow because of this resistance. Same kind of thing in electrical current. Resistors are the components that create resistance, right? So this is a resistor. It's reducing the flow. So there can be a number of resistors, right? The light can be a resistor. The wire can be a resistor. All of that just impedes flow. Like very little if it's a good conductor. But this might actually have a lot of resistance to it. An old incandescent light, essentially is a little heat element. So there's a lot of resistance there. All right. A few more slides. We're not going to do this whole thing. This is a big slide pack. So a multimeter is a tool used for measuring. One of these days in the lab, we'll play with multimeters and see if we can understand how they work, and also do some measuring with them. So measuring voltage, this is a standard multimeter right here. Usually has a red and a black lead. It's going to have a range, and it's going to have alternating current and direct current, right? So direct current is like 12-volt battery, and alternating current is like household. Okay. So set the multimeter to the proper range. You have to know kind of the range. And then you can use it to measure things. So certain spots, you can get different readings, right? So we can figure out what's going on with this voltage as it goes by a switch, a resistor, a light, see what those changes are. You can also do it with current. So over here, it's going to read that current off the meter. So you can do it at different spots to see what kind of resistance there is. So measures across component being tested. The power must be off or removed from the circuit to measure resistance. Yeah, so we'll do some of that, and you'll get a feel for different objects and different resistances. Ohm's law is what relates all three things together. So Ohm's law is V equals IR, or I equals VR, or R equals VI. So there's an easy way to remember that, and it's with the VIR triangle. So that's pretty handy. And I think, yeah, if you want to solve for V, it's I times R. Yeah. If you want to solve for I, it's V divided by R. So it's pretty handy little tool. So I like their little graphic. All right. The flashlight shown uses a 6-volt battery, has a bulb with a resistance of 150 ohms. When the flashlight's on, how much current will be drawn from the battery? So we can do our calculations. We know voltage and we know resistance, right? So let's see what they do. So there's a schematic for it. We have our little light here, and we have our battery source here. And we have our current. So we're going to cover it up. We're going to try and find the current. We're going to take the voltage 6 and divide by the resistance 150 ohms. And we're going to get 40 milliamps. So it's in a simple circuit, this is pretty easily done. All right, then they go on to talk about series circuits, parallel circuits. This is not electrical fundamentals. I'm going to stop here. But this does go through and actually walks you through a number of circuits, which is going to be handy when we go into the individual renewables, because we're going to do some calculating with some circuitry. Like, we're going to understand how a solar panel works. It's a collection of solar cells that's wired up a specific way. So, you know, this knowledge is going to be fairly important when we get to some of the individual renewable calculations. All right, that's good for now. I don't really have a homework set on that. I just wanted to introduce that to you. We're going to use it as we move along. And that's it. Make sure you do the second hour of the movie and the third hour of the movie. I think most of you have already done the second hour. And post up your thoughts. I've also put up a Patagonia movie that I'd like you to watch. So it's under today, Wednesday, the 24th, and it's right here. Patagonia, the full story. So I'm going to circle back to that, but that's really the end of our conversation of sustainability. Next is going to be moving forward into the renewables and talking about electrical production. I'll make another lecture. No, I'll probably wait till Monday. So Monday we'll talk about your project and probably also do a lab class. So have a great weekend.